Okay, hello and welcome back to part 3. We'll just go ahead and jump right into it. Construct and simplify the difference quotient f of x plus h minus f of x over h for the following functions. Number 1 is going to be f of x equals 8x minus 5. Well, first I'll figure out what the f of x plus h is. And that's just going to be where I see an x in this one. I'll replace it with x plus h. I'll go distribute 8x plus 8h minus 5. Okay, so I have fx plus h. I have f of x. I'll just go ahead and put this in. So I have 8x plus 8h minus 5 minus 8x minus 5 over h. Well, 8x minus 8x, those cancel. And minus 5 minus minus 5, those cancel. So I'm just left with 8h over h, which we'll say is 8 when h is not equal to 0. They like it when you put this here, so we want to go ahead and say that. Explains why we can divide by h. If h was 0, we can't divide by it because that's dividing by 0. So, okay, for this next one, I'll go ahead and I'll work on the right side. Or f of x plus h here. Well, everywhere I see an x, I'll replace with an x plus h. I'll go and square this out. It's going to be 3x squared plus 2xh plus h squared minus 5 plus h plus 4. And I can distribute. So I have 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 4. That's f of x plus h. So I'll go back above. When I go ahead and I subtract my f of x from that, I'll get 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 4 minus 3x squared minus 5x plus 4. And remember, it's all divided by h. Well, 3x squared minus 3x squared, those cancel. Minus 5x minus 5x, those cancel. And 4 minus 4, those cancel. So what I'm left with is 6xh plus 3h squared minus 5 over h. Minus 5h. And all these h's should cancel. So I'm left with 6x plus 3h minus 5. This h doesn't cancel because it was h squared. And we're going to say when h is not equal to 0 once again. So h minus 5 is not 0. Okay. Now for the last one, probably, in my opinion, the trickiest one. First, I'll write out what my f of x plus h is. Well, it's going to be 1 over, and we're going to see the x and replace it with h plus 3. So when I do f of x plus h minus f of x, I'll have 1 over x plus h plus 3 minus 1 over x plus 3 all over h. To simplify this, I want to combine these two into like a single fraction. So I'm going to multiply the top and the bottom of this one by x plus 3 over x plus 3, and this one by x plus h plus 3 over x plus h plus 3. So what I get is x plus 3 over x plus 3 times x plus h plus 3 minus x plus h plus 3 over x plus 3 times x plus h plus 3 all over h. Well, now I can subtract across, so x minus x cancels, and 3 minus 3 cancels. So what am I left with? I'm left with a negative h over x plus 3 times x plus h plus 3. And this whole thing is divided by another h. And so I'm going to write this h on the bottom is h over 1. When you're dividing, because anything divided by 1 is itself. I haven't changed anything. Whenever you have two fractions divided, you can keep change flip, so I'll keep my top fraction the same. It's a terrible x, I'm sorry. X plus h plus 3. And I'll change this from division to multiplication, and then I'll flip over my second fraction. And these h's cancel. So our difference quotient is going to be -1 over x plus 3 times x plus h plus 3 when h is not equal to 0. And that is our final answer. Moving on to number 40, given x squared minus 4x and g of x equaling 2x plus 3, find f of g of x and then find g of f of x. Well, f of g of x, I like to kind of read this as like this. It makes a little bit more sense for me. So what I'm going to do is I'm going to take my f of x, and everywhere I see an x, I'll replace it with my g of x. So my f of x is x squared minus 4x. So instead of x squared, it'll be g of x squared, so 2x plus 3 squared minus 4. And instead of x, I put my gx again. And now I just need to simplify. So squaring this, 2x plus 3 times 2x plus 3. What's going to be 4x squared plus 6x plus 6x plus 9. Just foiling it out real quick. So 4x squared plus 12x plus 9. So that's 4x squared plus 12x plus 9. If I distribute that, I get minus 8x minus 12. So 4x squared plus 4x minus 3. So I'll put that over here as f of g of x. 4x squared plus 4x minus 3. Now going on to the next one, it wants g of f of x. Well, it's going to be pretty similar. It's going to be our g function with f plugged in. So in my g function is 2 times x. Instead of x, I'm going to put my f function, so x squared minus 4x plus 3. It's supposed to be a little bit easier to simplify. 2x squared minus 8x plus 3. We can't go anything further, so that's it for that one. Okay, going on to this next one, we need to write a variation model using k as a constant of variation for each of the following. So first one tells us the volume V of a rectangular solid varies jointly as the length and the width of the solid. So that means V is going to vary, put our k, and jointly means that we're going to multiply them, so jointly with length and width. And that's it for that one. So the time of travel, t, is inversely proportional to the rate of travel. So what that means is our t is going to equal, we always put our k here, and this is inversely proportional, so we're going to put it divided by r. And that's it for that one. This last one is going to be the circumference c of a circle varies directly as its radius. So c varies directly. It's going to be just something k times r. So directly or jointly, that means you're multiplying. Inversely proportional or like inversely, that's going to be like divided. And that's it for that question. The next one tells us that the area of a picture projected on a wall varies directly as the square of the distance from the projector to the wall. So that means that the area varies directly with the square of the distance. So I'll say distance is d, and the square of it is d squared. So our first question is, if a 15-foot distance produces a 36 feet squared picture, what is the area of the picture when the projection is moved 25 feet from the wall? Well, first we can figure out our k value given that initial thing. So our area is going to be 36. Work on the right side over here. It's going to be k times 15 squared. 15 squared is 225. So k will be 36 over 225. Using that, for the next one, I'm trying to find the area whenever my distance is 25. So 36 over 225 times 25 squared. And plugging all that into my calculator, I get, didn't mean to erase, an area of 100, and it is to be feet squared. I keep putting on eraser. Area equals 100 feet squared. Okay, this next one is giving us instead the area, and we need to find the distance, so that we know that 144 is going to be, well, it's going to be 36 over 125, because that's our k. Our k doesn't change, times distance squared. Well, multiplying over the 225, so 144 times 225 divided by 36. It's going to give us our distance. Our distance squared, and I believe this is going to be 900. Plugging in my calculator equals d squared. Square root of 900 is 30, and that is our distance. So it's going to be 30 feet from the wall. So for the next one, we once again need to use a variation model. The stopping distance of a car varies directly to the square of the speed of the car. So it means that the distance is going to be k times the square of the speed, so s squared. S is our speed. If a car is traveling 50 miles an hour, it's a stopping distance of 170. Find the stopping distance of a car that is traveling 70 miles an hour. Okay, so we know that it's 170 whenever you're traveling 50 miles an hour. So it means our k is going to be 170 over 50 squared, which is the same thing. 50 squared is 50 times 50, 2,500, which we can simplify down to 17 over 250. So that means that we need to find the distance whenever our speed is 70 miles per hour. And just plugging that into my calculator, 70 divided by 250 times 70 squared. Sorry, 17 divided by 250. That's my bad. Times 70 squared. That is 333.2 feet. And that is our final answer. Next up, it gives us the function when you find each of the following, using completely the square to write in vertex form. See if it opens up or down, find the vertex, say if it's a minimum or maximum, and then say the domain in range. So, in order to put this in a vertex form, what we're going to do is I'm going to put my x stuff first, and I'm going to put a little gap, if I can put a little gap between that and my 3. And from there, for the x, my bad, I'm going to pull a 2 out of just the x terms, minus 2x, and I'll keep my minus 3 over there. And now I'm going to complete the square on the inside, so I'm going to take this number here, which is minus 2, divided by 2, get minus 1. Minus 1 squared is 1. So I'm going to add a 1 in here, and on the outside, I'm going to do something else. I'll explain it in a second. So first, I'll add the 1 on the inside, 2x squared minus 2x plus 1. On the outside, I'm going to subtract the 1, but I'm going to multiply it by whatever number's in front of here. The reason is, this 1 right here needs to cancel out with this, and this 2 is distributed onto that 1. So 2 times this 1 needs to be canceled by a negative 2 times the 1. So that's kind of the logic there. Make sure you remember to multiply it by the other thing. And that minus 3 is still there. This part will factor. So I'm going to factor x minus 1 squared. You see that minus 1 up there. That's not a coincidence. Minus 5. And that is in vertex form. So I'll write it a little small up here. Fx equals 2x minus 1 squared minus 5. Okay. So if it opens up or down, we can tell. We can look at whatever this thing right here is. If it's positive, it's up. If it's negative, it's down. So that opens up. Our vertex, well, this is vertex form. It's always h comma k. So it's going to be, our h is 1. And our k is going to be minus 5. We switch the sign on the one on the inside, but not the one on the outside. And because this opens up, if this is our vertex that opens up, is that the bottom or is it the top? Oh, so the bottom says the minimum. Minimum. And what is the minimum? -5. In our domain, well, it's a parabola, so our domain is just going to be everything. We can plug any number in and we'll get out an answer. But our range, well, our lowest is going to be -5. It can be everything above. Okay, going to this next one. This next one's like basically the same thing as part A of the previous. Find the vertex of the function 4x squared minus 24x plus 11 using the vertex formula. So I'll write this out again. X squared minus 24x plus 11. I will pull out my 4 out of my x terms. And I'll put this plus 11 over there. Then I'll take this term on my x. It's my 6. You always divide it by 2. It's always 2. -3. -3 squared is 9. So I'm going to add that on the inside. And on the outside, I'm going to subtract it times whatever is in front. Now, this inside is going to factor x -3 squared, including the square that always happens. Then -36 plus 11 is going to be -25. And then we're done. X -3 squared minus 25. Okay, next up we have a professional skateboarder. It gives all this information. The big thing is just gives us this equation where h is the height and t is t seconds after he leaves the rim with whatever the skate thing he's doing. Determine the time at which he reaches his maximum height, round 2 decimal places. So what we could do is we could go and write it in vertex form, and then we'll have our max, like when the time he reaches his maximum height. And that's totally fine if you want to do it that way. It might get a little bit ugly because these are some uglier numbers. There's also the fact that we can use is that you always reach your maximum height at -b over 2a. So in this case, it's going to be -5.4 over 2 times -4.9, which is the same thing as 5.4 over 9.8. The negatives canceled, which is about 0.55 seconds. And if you did this using like writing in a vertex form, you get the same answer. So 0.55 seconds. Seconds, if I can spell, after. Okay. Going on to the next one. What is his maximum height? Well, if we know when the maximum height occurs, we just plug that into our equation. So h of 0.55 is -4.9 times 0.55 squared plus 0.54 times, 5.4, my goodness, times 0.55 plus 3. And we should get around 4.5, rounding to the nearest 10th, meters. And that is his maximum height. And that's it for that question. For this next one, it gives us the spur problem is the braking distance of the car. Depends on numerous variables such as the speed, the weight, the reaction time, and the coefficient of friction. For a certain vehicle on one stretch of the highway, the braking distance are given for several different speeds. We use our calculator's regression capabilities, my goodness, to find the quadratic function to model the data rounded through decimal places. So, unfortunately, you can't see what I'm typing on my calculator, but on the TI-83, I go to Stat, Edit, I put in my data, and then from there I go to Stat, go on to the right to the Calc section, and I scroll down to the 5th one, which is Quadrag. Press Enter again, and that should give me all my values, and that gives me the equation y equals 0.039 x squared plus 2.532 to 3 decimal places, x minus 2.509. And after just writing all that, I realized that it's d of s, so s is our variable, not x, so I gotta replace all those x's with s's. And instead of y, we're trying to evaluate distance, so I'll replace that with d. So the distance is 0.039 s squared plus 2.532 s minus 2.509. You got something different, just be really careful with how you type your data into your calculator. You should have got the exact same thing. Moving on to the next one, use the leading term test to determine the end behavior of the polynomial function. Well, it gets us this. Our leading term is the term with the highest power of x, so it's going to be 549 is pretty big. So we're going to look at our power, 549. Is that even or odd? It's going to be odd. So odds normally look like this. Or they can also look like this in terms of our end behavior. Well, we can determine which one it is basically by looking at this and saying, is that positive or negative? Well, that's positive, so that means it's going to be the normal one. So we can, we can write it like that. You can also say like right up, left down, or something like that. But generally, you want to say that because the degree is odd and our coefficient is positive, the right side is going to go up, the left side is going to go down. Okay, for this next one, find the zeros and multiplicities of the function. Well, to find our zeros, we're going to set each of these individually. We'll set each of those equal to 0 individually, and we'll solve. We'll say zeros first. 4, minus 3, minus 5, and minus 2. And I'll put my multiplicities under it. Well, it's how many times they repeat, and we can determine that by the powers up there. So this is 2, this is 3. This one, there's no power up there, so it's just a 1. And this one is 4. And that's it for that question. Moving on to the next one, it says use long division to evaluate that. So I'll put the thing we're dividing by, thing we're dividing, pretty long one. So minus 3x, or just not minus 3, minus, sorry, I wrote this down wrong, minus x plus 4. Okay, I'm glad I caught that before I got too far. So when we do long division, we're going to look at this and this. The question is, what do I need to multiply this one by to get to the other one? Well, I need 2 more x's, so I'll have an x squared. And to get from 3 to 12, I need to multiply by 4. So from there, I'm going to subtract. And what I want to subtract is this 4x squared times each of these. So 12x to the 4. 4x squared times minus x would be minus 4x to the third. 4x squared times 4 is going to be plus 16x squared. And remember, I'm subtracting these, so the signs are going to flip. So 12 minus 12x to the fourth minus 12x to the fourth, so those cancel. Minus 4x to the fourth minus minus, so minus minus becomes plus. These cancel. 13 minus 16 is going to be minus 3x squared. And then this 2x gets brought down. And this plus 1 also gets brought down. Okay, now the next thing we got to do is when you say, okay, what do we need to multiply 3x squared by to get to minus 3x squared? And that's just going to be a minus 1. So multiply everything by minus 1. And then subtracting, well, minus 3x squared minus 3x squared become, those cancel. 2x minus x is going to just be a single x. And 1 minus minus 4 is 1 plus 4, which is going to be 5. So our quotient is the thing on top, 4x squared minus 1. And our remainder is going to be the thing that we're left with, but we need to put it over the thing that we're dividing by, because this part right here is still technically getting divided. It's just we can't see it further. It's gone too small. And there's that one. Next one is use synthetic division to find the quotient and remainder. Well, when I do my synthetic division, I'm going to take this and I'll say, okay, what, this like -2, I'm going to get positive because 2 minus 2 is 0. So it's like, I'm going to find the 0 of the bottom. 2. And I'll list all my coefficients. So it's going to be 2, 13, minus 3, minus 58, minus 20, and 24. Put a little line here, I'll put a dotted line here. Whatever I get here is my remainder. So, when I do synthetic division, I bring down the first term. Then I multiply them together. So 2 times 2 is 4. I add them together. So 17. 17 times 2 is 34. Gives me 31. 31 times 2 is 62. As we add those together, I can just get 4. 4 times 2 is 8. Minus 12. Minus 12 times 2 is minus 24. Add those together, we get 0. So we'll have a quotient. And our quotient is going to be this thing, all of these, but we're going to put coefficients back onto here. Note that whenever this starts with an x to the 5th, when we do our synthetic division, it becomes the x to the 4th. So all our, like, the first term goes from the 5th to the 4th. It drops 1 power every time we do a synthetic division. So see if I have enough space here. 2x to the 4th plus 17x to the 3rd plus 31x squared plus 4x minus 12. Sorry, that's not super legible. I'll write it over here, and then I'll erase it, go on to the next one. Plus 31x squared plus 4x minus 12. And our remainder is 0. This one we just happen not to have a remainder. Okay. Going to this next one, find out the 0 is a polynomial function, get that thing, given that 2 and minus 5 are some of the zeros. So what we're going to do is we're going to start off with the things that we know are zeros, and we'll do synthetic division. So 3 minus 13 minus 9 and 30. Bring down the 1. 1 times 2 is 2. 5. 5 times 2 is 10. Minus 3. Minus 3 times 2 is minus 6. Let's get minus 15. Minus 15 times 2 is minus 30 and 0. And because we knew there were zeros, we kind of knew that like the remainder should be 0. If you get a remainder other than 0, and you're told that 2 is a 0 of the function, then you did something wrong. And I'm just going to go off of the one that we already have reduced. And we're just going to do synthetic division on what we have left. So my remainder thing is going to move over, because now this is the last one. So bring down the 1. 1 times minus 5 is minus 5. 0. 0 times minus 5 is 0. Minus 3. Minus 3 times minus 5 is positive 15, which gives us 0. So we did all this synthetic division, but like, how does that help us? Well, this started as an x to the 4th, and now became an x to the 3rd, and now it's a x squared. So it means if I rewrite this bottom one, it's x squared minus 3. And I find the last two zeros, I just set that equal to 0 and I solve. So x squared equals 3. So x is plus or minus the square root of 3. So what were our zeros? Well, our zeros were x equal, wrong one. X equals 2 minus 5, the positive square root of 3, and the negative square root of 3. And those are all of them. Next one, I need to find a degree 4 polynomial linear form with rational coefficients, given that I minus 2 and 4 are some of the zeros of the polynomial. So, first off, whenever we know that I is a 0, minus I will also be a 0. So writing these out as factors, we can go ahead and multiply these out. So it's going to be x minus I, x plus I. This would be x plus 2, because if I plug minus 2 into this, minus 2 and plus 2 cancel out, and then x minus 4. I'm going to multiply these two together first. So it's going to be x squared plus ix minus ix minus I squared. I squared is negative 1, and these cancel, so x squared plus 1 times x plus 2, x plus 4. And I'll just go ahead and keep multiplying. Just keep coupling together. So if I multiply this out, I get x to the 3rd plus 2x squared plus x plus 2. And unfortunately, I can't combine anything there. And I just came back to this because I realized I did the rest of the problem wrong, because this was an x plus 4 and x minus 4. So unfortunately, you guys missed out on some great content of me doing math that was incorrect. Okay, so when I multiply these two out, I can multiply my x on everything, I can multiply my minus 4 on everything, and then I can put them together. So x to the 4 plus 2x to the third plus x squared plus 2x, and then multiplying by minus 4 and everything, I'll have a minus 4x to the third, a minus 6x squared, a minus 4x, and a minus 8. Oh, that was supposed to be a minus 8x squared, my bad. Sorry, minus 4 times 2x squared would be minus 8x squared. So whenever I add all this together, x to the fourth, minus 2x to the third, minus 7x squared, minus 2x, minus 8. And that is my final answer. That is a polynomial degree 4 with rational coefficients, with I, negative 2, and 4 as the zeros of the polynomial. So go ahead and I'll rewrite this up here. I'm going to keep going on from there. Going to this next one, we're going to find all the possible rational zeros of that function. Well, it's going to be all the possible p's and possible q's. Our p's are going to be the factors of the last thing. So our list of things for our p's are going to be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8, because those are all the different things that can multiply to be 8. And our q's are going to be from this first one, so plus or minus 1, and plus or minus 2. And our list of possible rational zeros will be every p over every q. So I'll put my list here. So it's going to be plus or minus 1, because 1 over 1, plus or minus 2, because 2 over 1, plus or minus 4, 4 over 1, plus or minus 8 from 8 over 1. And then plus or minus 1/2, because it's 1 over 2. I'm going to redo that so I can actually read the next problem when we get there. Plus or minus, and then 2 divided by 2, well, that's 1 already. 4 divided by 2, that's 2. 8 divided by 2, that's 4. So we don't have to worry about any of the other ones. That is our final list. For this next one, we got to find our vertical asymptotes of this function. Well, our vertical asymptote is going to be when the bottom of the function equals 0. So we'll say x squared minus 3x minus 18 equals 0. And we'll go ahead and solve. So it's going to be x minus 6, x plus 3 equals 0. I should specify that if one of these terms is also on the top and they cancel out, it's not going to be an asymptote. It's only asymptote if it doesn't cancel out. In this case, because neither of these were x minus 2, we don't have to worry about that. But if one of these were x minus 2, we would cancel them out. So it would still not be defined there, but we wouldn't be an asymptote. But in this case, it doesn't happen, so it should be at x equals 6 and x equals minus 3. For horizontal asymptotes, will be a bit different. What we're going to do is we're going to compare the degree of the top and the degree of the bottom. So the degree of the top is 3, degree of the bottom is. This 3 degree is just the highest power on top and bottom. If the bottom has a higher power than the top, then it's always y equals 0. If the top has a bigger power, then there is no asymptote, horizontal asymptote. There might be a nonlinear one or a slant asymptote. You're going to see that in the next 2 questions. But, no spoiler alert, but that might be coming up. If they're the same power, you're just going to take the coefficients, which are the numbers in front, and you're going to divide them. So in this case, it should be y equals 3 over 8. And we're done. The next one to find the slant asymptote, that happens when the degree on the top, the biggest power on the top is 1 more than the biggest power on the bottom. And what we do is we do everyone's favorite, long division. And whatever we get on top of this, that's our slant asymptote, and we just get to ignore our remainder. So What do you multiply x squared by to get to x to the third? Well, it's another x. Multiply each of those by x, and then we're just subtract them. X cubed minus x cubed, those cancel. 3x squared minus 2x squared is going to become a 5x squared. And these just come down. So what do I multiply x squared by to get to 5x squared? Well, a 5. And technically, our remainder doesn't matter, but just to go through it just for the practice, x minus 10 is going to become x, or negative x plus 10, which is going to become 9x minus 3. But our remainder doesn't matter because our same asymptote is y equals x plus 5. Moving on to number 58. Our nonlinear asymptote, we're going to do the same thing. We're just going to do our long division and we're going to ignore our remainder. So x squared plus 3x, we're going to divide x to the 4 plus 3x to the third minus 5x squared plus 2x minus 6. Well, what do you need to multiply x squared by to get to, x to the fourth? Well, you need another x squared. So multiply x squared on both of these, x to the third. And then when we subtract these, x to the fourth minus x to the fourth, those cancel. My goodness, I cannot write. Those cancel. 3x to the third minus 3x to the third, those cancel. So just these terms get brought down. Minus 5x squared plus 2x plus 6. Sorry, minus 6. And what do I need to multiply x squared by to get to minus 5x squared? Well, it's going to be minus 5. And again, the remainder doesn't really matter here, but we'll go ahead and do it just for practice. Minus 5x squared minus 5x squared, those cancel. 2x minus 15x becomes 2x plus 15x, which is 17x. And the minus 6 will just drop down. But our nonlinear asymptote is y equals x squared minus 5. And that's it for that. Thanks for joining us for this part. We'll have one more part out, and we'll try to get it out soon. Good luck on your final.